Good afternoon. Thank you for that introduction. Thank you for needing us for today's event. And thank you for ZenFi for sponsoring this panel. I'd like to introduce some of our panelists. From right to left, we've got Ken Sandfeld. He's the EVP of Solid. You have Ray LaChance, who's the President and CEO of ZenFi Networks. Joshua Broder, who's the CEO of Tilson. And you have Mark Parr, who's the President of Bandwidth Logic. The format that we're going to be using for this panel is a little bit of a Q&A. We're going to be light on slides. I have a couple in the very beginning that we're going to be going through. And towards the end, time permitting, we'll go to some questions. So starting with the first question to the panel, what is your definition of base station hoteling and its importance to the wireless industry? Ken?
Hoteling, in my view, is really the location of the RAN assets in one central location. So, by putting all of the more expensive, more complicated assets in one location, you can service them, you can scale them better long term, and you can provision them long term. So it really is a central location, right, where that is all taking place, versus a distributed approach.
You have some slides you'd like to?
Yep. Want to stand up? Oh, I should have put that up earlier. So we're going to talk to you about micro solutions. We're going to talk to you about the city core, Cloud RAN, C-RAN, but really what drives how much capacity is needed on a pole. What drives that capacity? Obviously, it's users. I get that. But really, what drives the capacity in terms of technology? Is it baseband processing? Is it the RF on the end? Obviously, it's all of it. But where are those RAN resources located? Are they located on the pole, like small cell, or are they located, baseband unit with a radio head separate? Different topologies. What does future scalability mean? We all talk about 5G. There's LTE-U, right? That's going to be coming up, right? So how could that play into it? How does that play in the outdoor areas? A lot of cities are deploying Wi-Fi, while LTE-U might end up being a part of that as well. Where is the silver bullet? So I produced a slide real quick. I apologize, it got a little messed up in the conversion, but if you follow the little yellow lines, I think you'll figure it out. So this is obviously focused on fiber because I'm a fiber optic product electronics company, so we're focused on fiber. However, after the aggregation points to the right, there perfectly could be some great opportunities for microwave, millimeter wave type of applications as well. So I'm not trying to say that there aren't any other solutions. But here, most importantly, I'm trying to illustrate the three types of technologies. So today, and this can be considered a small cell as well, I guess, CPRI radio heads, where you have a baseband unit and a radio head. Those are a pair, and they're matched together. There's typically not a routing function. There's typically not a daisy chain function, and most of the time it's considered a fiber cable, right? Typically, those are going to be CPRI or OBSAI fed. And you're going to have several bands of MIMO capability, and you're going to put that on the pole. There is ways to daisy chain it using WDM optics, which I'm showing there. So there are ways to daisy chain CPRI, even though it's not part of the native spec, which allow you to put repetitive poles all on the same fiber strand for efficiency. Gigabit Ethernet small cells, essentially very similar in architecture, except the fact that you're distributing Ethernet, and there's no proprietary, there's no RF packets, if you will. It's all standardized Ethernet, right? Once again, you can daisy chain that using WDM optics as well. So that's another tool in the toolkit. Lastly, if you can see that on the bottom there, the next generation of DAS solutions are also going to provide an opportunity for some really neat applications to drive higher capacity and more bands and more RF at the dense urban deployment. So what I'm showing here is the ability to put CPRI across the DAS to a radio head. I'm also showing the technically that little box is supposed to go around both of those showing the combination of baseband and radio, essentially an Eno B at the front end of the system, driving the DAS remotes out there in one location. So basically the same as putting BBU and RHU together. But most importantly, we're mixing and matching CPRI and RF to aggregation points and out to remotes. So the main point I want to make here is, where do the radios go? Where do those assets go? You asked me the question about hoteling. Well, the reality is all these applications are taking advantage of hoteling, but they're not all taking advantage of having the expensive assets in the hotel on the left of that line. A lot of, like for example, the small cell has a lot of that processing being done on the pole, whereas more of the DAS has all of it being done at the hotel. And one would argue that the baseband radio head unit has kind of a split, capability as well. So my goal of this slide was to kind of just to remind everyone kind of the options that are available and how things are starting to flush out. The biggest difference in all of these is really that the DAS is still king on number of bands and total spectrum in terms of how much you can do on a pole in a very small space. However, there's other issues with DAS versus some of the other solutions. So anyways, hopefully that helps kind of explain some of the options and the way things can be done as we talk about the CRAN and Cloud RAN networks.
What is hoteling? Any other comments from the panel before we move on to the next question? Anything you'd like to add? So what is the importance? Why now? Why is this a relevant topic to the industry today?
Well, excuse me, I think it's part of the natural evolution in the mobile wireless space. Our goal in the future is to get as much mobile connectivity as close to the user as possible to increase capacity and increase bandwidth to end users. The way to do that is to densify the network. We see the base station hotel or the base station aggregation POPs that are geographically located near the antennas but not at the antennas as a very important component of this densification of the wireless network. So we envision a network with many hundreds of thousands, tens of thousands, or hundreds of thousands of antenna locations that aggregate at a point that has intelligence where you can have economies of scale operationally and economically that ultimately get aggregated back to an intelligent core of a mobile network. So it's a core building block for the future of mobile networks.
From a technology perspective, are there any key technologies that are enabling this to happen now?
So clearly we need to look at the way the fiber networks that support the antennas today are architected. Today you have the traditional model of a backhaul from a macro site or a small cell or from an aggregation point for outdoor or indoor DAS. Ultimately, the network requirements are driving the need for speed and low latency to reach those antennas. We just talk about the CPRI protocol, which has requirements for 600 megabits up to 9.6 gigabits of bandwidth, and we're sub or multi-microsecond latency requirements. The only way to accomplish this is to have the base station as close to the antenna, the base station computing resources as close to the antenna as possible without being at the antenna. So we see this concept of front haul fiber and deployment of radio over fiber technologies as being an important piece, and it's going to require re-architecting of the fiber infrastructure that's out there today.
So sticking with front haul for a second, what mobile technologies can be supported on a front haul network if it would be deployed?
So I could speak to that. So what we're seeing in the field is front haul fiber networks, and those are fiber networks that provide connectivity from an endpoint and antenna somewhere back to some kind of processing technology or amplification technology back in a shared location prior to it being backhauled, are being used across a variety of technologies. We're seeing several flavors of small cells that operate independently as if they were discrete sites, but where the carrier still wants to share a common point of backhaul and not backhaul directly from the site. We're seeing small cell technologies that require control systems like small cell BBUs that are back at a hotel location, so it can't quite stand on its own. And we're seeing lots and lots of DAS facilities. And I think what's exciting about this time is that the form factors of these nodes right out on the edge where the antennas are, is that the form factors are increasingly getting smaller. And one of the necessary outcomes of the form factor getting smaller is that more of the intelligence and processing and amplification are being pushed back to the point of demarcation between the front haul network and the backhaul network. And that's really where the idea of hoteling is so critical.
I guess, why is it such a big deal? There's tons of fiber out there today already. So what makes this different?
Oh, I get to answer. Well, I think really Ray can back me up on this. He's more the outside plant guru sitting on this panel. But when fiber optic systems are put in the ground, especially let's take Manhattan for example, they're really not point-to-point per se. They're ring topologies. The finances of putting that fiber in is based on a return on the model, how much they're going to get. A lot of lit services, managed services. So now we're not talking about lit and managed services. We're talking about essentially leasing dark fiber out for the most part in one aspect of a model. There could be a managed service model as well from, say, a neutral host or like a ZenFi. But it's really more of a hub and spoke type of architecture that you're going to start looking at. So you could utilize some of the fiber that's out there, but it's really, you kind of need to lay the fiber in the ground with the intent of having a hub and spoke architecture.
Right.
Hey, let me follow on with that. I think that's absolutely right. I mean, we've had experience of putting up nearly 2,000 outdoor DAS nodes throughout the city using traditional techniques of laying big fiber optic cables and accessing them, bring them to light poles and street poles. And during that time, we saw that building these networks the way they've been built in the past with these large looping rings and very sparse access to them is certainly not the recipe for supporting the dense networks of the future. If you look at Manhattan, it's got somewhere in the neighborhood of 3,400 intersections in New York, in Manhattan alone. Right? Each one of those intersections ultimately should have an antenna someday, or multiple antenna locations. And to think of breaking into your cable every block all the way up Fifth Avenue using traditional fiber techniques just doesn't work. So the networks that are out there today are really not built for the amount of access and fragmentation that's caused by deploying these distributed antenna and small cell models.
I'd like to add to that. Let's define what densification is really going to mean. So for every site you see here in the city, imagine a 10-to-1 split. That is ultimately what's required to have any city, not just a big one like Manhattan or the city of New York. It's a 10-to-1 split. We've seen that in Asia when they went through this next step of densification. They took their, for every one site, they had to add 10 more. So they had to create aggregation points out of those existing sites or create new ones. So now just imagine how fast you're going to start burning through fiber if every link is a point-to-point. And I mean, you're going to be using every tool in the toolkit to get connectivity. I mean, it's quite substantial.
Yeah, I think just to add one last point, and then Ray can correct me again. So instead of necessarily, I called it a hub and spoke. I mean, it could be a backbone run up an avenue, but it's when you're going down the streets that almost like an Ethernet, you're having drops down streets, pull it back on a common backbone. So it's still a hub and spoke graphically on paper, but it almost looks like an Ethernet essentially.
That's right.
So thinking about the fiber and the outside plant, there's this other concept of the hotel. What is the hotel? How many carriers need to be in a hotel? And what can a hotel support?
That varies. The real model it depends on how sophisticated you are in building out a hotel. So the ultimate cost savings here, just from my experience, I'll use rough numbers. I've built a lot of DAS networks in New York City alone. And typically you're going into Class A office space, even trying to find space in the basement of a Class A office building, it's not easy. In some cases, I built 30 Rockefeller Plaza some 10 years ago. Getting power in that building was a challenge because of how much the studio draws already. But so now you have to look at that equation and say now you're not taking up Class A office space. You're aggregating multiple base stations together in one location. You're also minimizing not only the carrier's insurance requirements because they might not have to deal with the DAS anymore. That might be the enterprise or a neutral host or other maintenance provider. Gaining access in buildings in Manhattan is a challenge. So now you're not accessing 3,000 buildings, maybe you're accessing 20 or 30 base station hotels, meaning the carriers. Power aggregation, cooling, your backhaul alone is now, instead of having, let's say a gig access at every one of these buildings, you can now put 10 gig and bigger access backhaul transports together. So it's hard to give you a hard, firm number, but it would typically, to me, start at the range of at least having 5 distributed antenna systems or 5 base stations. So no matter the mix or match of carriers, to kind of cost justify building out that plant. And when you build the plant out, you might have, let's say you get 10,000 square feet and you get the first 2,000 with first right of refusal for the next part, and you only create hot and cold aisles in that one section, and you keep building that plant out as needed. You don't just go build out some big giant data center with Liebert units and et cetera, et cetera. Good plug for Liebert.
Making it scalable.
You scale it.
Right, and we're finding that as we deploy in different kinds of environments, what we call a hotel varies greatly. So in some of the dense urban areas within what we would traditionally see as C-like hotel kind of data centers or central offices, we see really big base station hotels coming in at the kind of multiples that we just talked about. But as we get more into the neighborhoods and the suburbs of the metro areas, we have what I'll call the base station in-law apartment. And the base station in-law apartment is typically a macro site. And at that macro site, which used to be a pretty full shelter, but as technology has progressed, has gotten to be an increasingly empty shelter, we're adding racks back to have very small DAS head ends or just additional racks of BBUs and controllers and additional radios to control much smaller networks. And sometimes those networks are in the 3 to 5 DAS nodes or 3 to 5 RRUs or 3 to 5 small cells. And because those communities are lower density, the necessary deployment is lower density, but some of these base station hotels are, in fact, co-locations on existing head ends, leveraging the existing backhaul without a backhaul upgrade.
With the base station hotel, is there a risk of putting all your eggs in one basket? What happens if one of them goes down? Isn't that a large area that could be without service?
It could be, but could consider every major financial trading entity in the city does the same thing. They're not all at their offices. It's not just J.P. Morgan has their data center, Goldman has their data center, et cetera, et cetera. They're all at least in 111 8th Avenue. They're probably in 60 Hudson Street. They may be in 32A of A. So if something happens, they would take out a significant swath of trading, quite frankly, millions of dollars a second, right? But that's where you build fortified base station hotels, just like a data center, a little bit different model where you're not charging like a data center. But a lot of other things can happen that can take out, in this modern day and age, without getting into the conversation, but there's a lot of things that can take out a lot. Built wisely, you can get something that's fortified, that's going to have a high degree of reliability, call it 5 nines, and have a backup plan to that as well.
I'd like to add to that. Clearly, there's a resiliency problem if you're going to home multiple, former macro sites, small cells, DAS, whatever, back to these aggregation points. It has to be built to a higher standard than the traditional cell sites are built today for resiliency. It may require, a better battery backup system, generator system, better cooling, higher reliability. That said, using today's model for the wireless space and having come from the optical networking space and seeing how enterprises and banks do the resiliency, there's a world of difference. The amount of resiliency that goes into a banking network is significantly greater than what happens in the wireless space. But what I expect to happen as the technologies develop and mature for the connectivity to the cell sites, and the cell sites become more intelligent, and we move from this consolidation to this concept of a cloud RAN model, I expect that we can build resiliency into the network just like we build into banking networks today, right? We go with optical path protection or other link layer protections, all the way to higher stack protections. So ultimately, when CPRI is delivered over Ethernet circuits instead of over a native physical link, those types of advancements in the technology will lead towards better resiliency in the network and less of your eggs in one basket.
And I might add, just to reinforce what Ray is talking about, I think as we're in the more fragile transition time to implementing more robust topologies and implementing data center level quality of service in our resiliency, in the short term, these densification networks are largely offloading data, and they're augmenting existing macro sites that will still provide some level of call completion, the level of call completion we have today in the service of public safety. So I think in the short term, I think what's really at risk is our ability to data offload and do the things we enjoy, but the ability to complete a 911 call, at least in the years while we're headed to a more virtualized processing space in clouds that are more resilient, is largely going to be dependent on good voice call completion until we're in a better place from a resiliency standpoint.
That's a great point.
You mentioned the term cloud RAN. Another term that's often used is CRAN. And sometimes CRAN is used as centralized RAN, cloud RAN. Could you kind of untwist that and distinguish what those might be and how they may be different?
Well, the reality is ultimately they mean the same thing. Like I said up here, where you're putting your assets. But the reality is it's really where are you doing your baseband processing. So, and how are you doing that, right? So right now we're talking about specific boxes that go into the hotel and that do that baseband processing and then put it in the CPRI packets or proprietary packets and get it out to a radio, right? Eventually, the cloud will really become a cloud. What do we determine? A cloud today, processing cloud, is just a bunch of racks of computers. And in the not too distant future, all the equipment that we're talking about putting in the cloud will just be that. It will just be a racks of CPUs that do all that call processing at that location. Ultimately, in a perfect world, the stuff that goes on the pole is as light and as low in complexity as possible. Things that fail, things that require upgrades, things that you have to touch. Think about if you did a 10-to-1 split upgrade in Manhattan and you had to go once a year and had to service every one of those. You don't want to have to touch them anymore. So the goal is to put as much of the stuff that you need to change or potentially repair if it fails in a location where you have access and you can touch to it. So ultimately, I believe they mean the same thing essentially, but from a cloud perspective, it refers to where that processing is being done. It's hosted,
So looking at base station hoteling, there's potentially a lot of stakeholders that can benefit from this. So as you kind of look to the future and the potential of base station hoteling being deployed in a micro solution, tell me a little bit about how the stakeholders, whether it be the carriers, municipalities, the end users, the landlords, could benefit. What are the benefits this brings to them?
I think one of there's a couple obvious benefits, right? The economies of scale that you get for capital deployment and the economies of scale you get operationally are fairly obvious. And how do they apply to a landlord? Mark mentioned 30 Rock, and it was hard finding space to put the head end. It was hard to find power. Well, the objective here with the base station hotel model or this aggregation point is to find a cost-effective space that can be conditioned to a point that it provides the reliability that you're and the access you're looking for, and then bring multiple sites in. And rather than having to solve that problem at 30 Rock and across the street at the other Rock Center buildings, bring those in-building data systems back to a central aggregation point and share in the economies of the CapEx for the base station, the CapEx for the cooling, and the power systems that are put into place. And then operationally, share on the backhaul. And, you know, as Mark said, a 10 gig backhaul comes into the base station hotel rather than a gig or 100 meg that would have been distributed out. Share in the OpEx for sparing and the ability to dispatch your text to a single location to work on the smart gear that Ken mentioned. And so I think there's economies of scale that are obvious, you know, with the from a financial perspective as well as an OpEx perspective.
And I think the idea of hoteling is inextricably linked to making the form factor of the remote nodes smaller. So as we seek to put these things more in the public way, out on utility poles, in increasingly high levels of finish, in office spaces, in really cluttered public shared utility infrastructure environments, necessarily we have to shift processing and other supporting technology back to a central location. And so I think not only does that allow us to get closer to our customers and put nodes down into the nooks and crannies, but it also allows the carriers and owners to focus their scarce CapEx resources on the very difficult work of getting into those nooks and crannies, which can be really challenging places from a real estate and an installation perspective, and hopefully be done with that real estate and installation job and be able to surf behind that with upgrades in the hotel for years to come.
Yeah, just to add to that is, we're all obviously here because of the proliferation of wireless, right? You know, I'm working on an opportunity, we've got a hotel secured, and the problem is, for the hotel is, it's 20-something stories, and it doesn't deserve a full-blown 3-sector base station, right?
Mm-hmm.
So do we just avoid those people going to that hotel? The hotel owner doesn't want to see that. They're like, my clients are going to want to use their cell phone. You know, excuse me, Wi-Fi, that's great. Maybe that gets prolific, or as prolific as the Wi-Fi people want it to be, which I believe it will also, but it'll be prolific right alongside with commercial mobile radio service. Now we could take that site that really only merits one sector off a 3-sector base station, and I could serve it off of one sector at a base station hotel, not spend $250,000 to fit out a head end. Again, it's not Class A office space, but it's a Class A building. It's a Midtown Manhattan hotel. I just solved the problem for that owner.
Right. And let's remember that it's still a fairly new concept. Not having a centralized CRAN and a remote radio head, that's not new. It's being done quite substantially. But the concept of a hotel serving in-building DAS, lots of in-building DAS systems, and there's also the concept of sharing, right? For the most part, carriers don't have a problem sharing on a DAS, but when you talk about an outdoor pole, they still don't like to share. And that's a concept that's going to, you know, it is economies of scale, right? It's like any other colo macro site, but the reality is when it comes to small poles, smaller type things, street furniture, if you will, the reality is they haven't figured out, you know, how to share. And the reason they haven't is because the small cells and things that are being deployed are single operator. So they're really cute and really sexy, and you put them on a pole and you can kind of not see them if you squint. and you know what, it's all done. It's like, yeah, that's great, but that's only one operator and he just took up a whole pole. And how many poles are there on a street, right? And that is significant. That's a technology barrier. It's a kind of a mind share of how people feel like they needed to go about it. But when we start the large scale deployments, you know, like the guys here have been talking about, those are where the issues are going to be huge, because we can't afford to hang 4 boxes on a pole, and we definitely don't want to put 4 pieces of fiber to that pole either. There's no need for that. So there's going to have to be some colo. There's going to have to be some sharing of fiber resources. There's going to have to be some sharing of resources on the pole. And that is, I think, a big thing that is yet to really happen in a big way, like it is for DAS and other things.
So taking what you just said, talking a little bit about concepts, can we turn this into some reality, some real examples of why this is exciting for your company, each of you, and examples we've worked on these projects that were able to leverage this type of an ecosystem, although it may be still emerging. Do you have examples where you could cite where this has been something successful for you?
I'll start with that. So most of our experiences come from Asia, who's done most things first before they actually happen here. We have the largest centralized Cloud RAN deployment in the world, in Gangnam and in the surrounding areas in Seoul. And now these are front haul CPRI fed radio heads. They're not small cells, they're not Ethernet, anything like that. They're true CPRI fed. But they totally gutted the existing fiber network to build a whole new ring and star topology in order to accommodate the scalability of these networks, and as well as future space on the poles. And they're poised for any new technology that comes. Even if they got rid of the CPRI and went to Ethernet, or even if they got rid of some of the Ethernet or CPRI and went to DAS, their network will accommodate anything. And that's really what we're going to have to do in this country as well, because the reality is it's not going to be one size fits all. There's going to be some places where fiber is needed, some places where millimeter is going to take place. But the reality is all those things will be required in order to make it happen. We've already seen, you know, any of you travel to Asia, you'd be blown away by the data speeds and the coverage. They have both. Coverage and data speeds, you know, and you come back here and you're like, oh my gosh, you know, I got 1 bar, you know, of nothing here, you know, and you're happy, you know, I got LTE, I got 1 bar, and why is that? It's because they've basically bit the bullet, all right. On one of my slides, I put, what's the silver bullet? There is none. You know, technology can make up for a bunch of gaps, and there's a lot of cool stuff coming, you know, that people make. But the reality is that at some point you got to build a topology that you can scale. You know, whether it's LTE or whether it's 5G or whatever is coming, you got to have a system where that when that year comes, rather than completely rebuild your network again, you're just changing boxes. Everyone knows we're forever in this industry going to be changing out cards. And like you were talking about, you know, what used to fill up a whole shelter full of TDMA radios or even CDMA radios is now one little rack of stuff, right?
Tell them what you really mean. There's no such thing as future-proof.
There isn't future-proof, but yeah, you got, you know, but now all these shelters are like, so in Asia, for example, they had shelters. They had the same situation. What do? They turned those shelters into huge fiber aggregation points. They're like, well, hell, we got this beautiful building. It's air-conditioned. It's got halon. It's got all these great things. Let's just put a big, gigantic fiber switching plant system in here and create a very robust fiber network. So there's a lot of opportunities. You just got to, you know, bite the bullet.
Other examples?
Well,
Go ahead.
Well, I mean, I could give Ray's example for him. He's probably put more fiber in the ground and more units on poles throughout the city. It's a similar architecture, right? I guess what he said before is they've learned from their ways of how to more efficiently lay fiber in the ground. I don't know how many years it is now, maybe 10, 12 years ago, I was with a company that founded Transit Wireless doing the New York City subway, and this was the core of our architecture. It's base station hotels being built around the city as we speak. There's some up and running right now. They're running fiber through the streets on a hub and spoke architecture going down into the subway network. We had the opportunity to put that fiber in the subway tunnels, which was basically MTA right-of-way, which is a state entity. You know, I opted to keep it out of there because we wanted to be able to play in the field and actually feed buildings. And it took me years, but I kept telling carriers, base station hotels, until one finally came to me 2 years ago and said, hey, can I use this base station hotel to feed other buildings I'm in? Yes, and it's a working model.
There you go.
Yeah.
Right here.
We've primarily deployed pole-mounted nodes, and the carrier's willingness to hotel either in the in-law apartment style at an existing macro or at a dedicated, more sophisticated, high-density hotel has really enabled us to focus on getting out onto the utility pole lines and doing pole licensing and installation. And what's really fun about it is that once the carrier's made a decision that they're willing to hotel the facility, it allows us in the field to go think about what the right technology is to solve the problem in that particular area. And we've talked about all those technologies already, pushing RRHs out in kind of a CRAN topology, in ODAS facilities, and various flavors of independent or semi-quasi-independent small cells, all sharing common backhaul. So our real world success story this year is being able to deploy 1,000 of these and having the hotel be a non-issue. The hotel is taken for granted, the carriers are doing it, they're happy with it, and our focus really is around getting the nodes out into the nooks and crannies and being as close to the customers as we can.
Sure. Let me just throw out one last comment. I had an epiphany about this about 4 years ago, 5 years ago. We had just sold our company, LaChance, that was in the fiber asset business and construction business. And from 2007 through 2010, we put up approximately 1,600 or 1,700 outdoor DAS nodes. When we were building those nodes, we were bringing them back to base station hotels because that's what you had to do with outdoor DAS. There's no other place, right? So at that point, we had sold the fiber business. We were thinking about what we wanted to do in the future. Started getting excited about mobile growth and all the opportunities out there. And then I started looking at the infrastructure that was supporting the mobile world today. Besides, we learned a little about DAS by doing those nodes. We looked at macro sites. We looked at the concept of small cell, and we had, in fact, we put up about 100, 150 or so small cells. And we started to realize that this concept for base station hoteling made sense when we looked at opportunities coming to us for in-building systems. And every in-building system had a riser, a fiber riser, had remotes on floors, had an aggregation point in the building, which is great, but it also had a base station in the building. Then next door, we'd get a request for the building a few doors down. And guess what? It had the same base station aggregation point. Then we'd see all these in-building requests, and I was thinking, well, for outdoor DAS, when we put it on the 50th floor, when we put it on 34th and 5th, we had a remote there, and we'd fiber back to the aggregation point, and it connected to a base station. What's the difference if it's the 50th floor of an office building and the 34th floor of an office building? So I saw that, and then we started looking at macro sites, and I saw you see all this equipment on macro sites, and there's about 2,000 macro sites in Manhattan today, and every one of those has all this equipment on the roof. And I'm thinking, why is that base station there? That doesn't need to be there. So if we have this tenfold increase in sites, and I think it's going to be even bigger than that in New York City, it's probably going to be 100,000 antenna locations in the city of New York. This is the only way to do it, is to follow this model of aggregating all the intelligence of the mobile wireless network, move it closer to the core, put the low-cost assets out on the edge, and support it this way. So from my perspective, as a fiber guy, certainly not in the class with these wireless guys, and nowhere near their experience, it just doesn't make sense the way you guys had built these networks in the past.
Well, it's really an exciting time to be thinking about doing this cost effectively, because today, the equipment that's going into the base station hotels, most of it will inevitably be virtualized. But the necessity to provide fiber out to these antenna endpoints will exist after the virtualization moment happens. In fact, it'll be more important as that loop is extended from the antenna all the way back to some cloud computing facility. And so today we're calling it a base station hotel, but it will essentially become an aggregation point. And the point of demarcation between what today we're referring to as the front haul network in a transitional environment and the backhaul network will converge. And what will be left in the wake of these base station hotels will be places where we can get fiber from existing backhaul networks out to the sites, and essentially we're building the backhaul networks of tomorrow and our front haul networks of today in anticipation of this virtualization.
Well, thank you. I'd like to take some time to open it up to the audience for any questions they'd have for the panel.
Excellent.
No digesting lunch, perhaps.
You got nothing?
We have one over here, okay, hold on.
How you doing? Jordan Fry from Snyder & Snyder. My question is about how many square feet does a base station hotel take up, and what type of properties do you target when you look to find a base station hotel?
Why ask me?
It depends, I think.
It depends.
Jeff is out there laughing somewhere, and Carla. It really depends. The 30 Rockefeller Center is probably my life nightmare of base station or head ends, whereas we had to work really hard with the carriers to slim down their gear. We got it all done, and about 6 months later, GE said they were selling that floor, so we had to move the head end. We moved the head end to the 7th floor, right down the hall from the NBC commissary, and Jimmy Fallon got his own show, and he said, I want the 7th floor by the commissary, move your head end. And it's been moved 3 times, by the way. But in one case, we had probably about 700 square feet. In another case, the first case was actually probably about 400 square feet. I always use around 600 square feet as a good number, and it's growing. It's kind of growing and it's shrinking. It's growing because we're getting more bands deployed. You know, we're going to have 600 megahertz auctions hopefully someday, and other bands are going to keep coming, but technology is shrinking as well. You know, one of the biggest things that I've been pushing for years is, you know, a laser really like 0 dBm. For those who non-technical people, that's 1 milliwatt. And that's all things combined onto one of Solid's lasers, for example. All those technologies, you just attenuate them down until you get down to that low level. But carriers are still handing us base stations that are putting out 40, 50 watts, and we don't need 40, 50 watts. We just attenuate it, but then we're cooling, we're providing power for that, cooling for that. So you're gonna see that's a good question, but so in today's day and age, I say 600 feet, that would be in one building. That becomes more efficient and probably gets down to about 350, 400 feet in a base station hotel because you're sharing facilities. And again, it's going to start getting smaller as we start getting away from this amplifier mentality at the base station. We get more into IP technology and more of I'll call it a traditional C-RAN type of smart networks.
Yeah, and to elaborate on that for a minute, one of our favorite things to do with small cells is to use them at a base station hotel downstream of a DAS system so we don't have to attenuate radios. If you're going to amplify anyway, you might as well start with a really small radio. So we're building an ODAS, a pole-mounted ODAS system in a small city, about 150,000 people kind of size city, maybe 100 remote pole-mounted nodes. And all of the ODAS head-end equipment and the attendant banks of small cells that'll inject RF into that ODAS are probably 8 racks. Rough size for 100 remote nodes.
For a true, hotel colo that serves lots of buildings or poles or what have you, I would use more the analogy of you building a data center, right? More than square footage. So with a data center, you need cooling, and you need power, and you need fiber. You know, and so if that's not already, if you can't figure out how to make that work, then that building is probably no good, regardless of how many square foot you have. It has to be secure and not waterproof, hopefully.
It's nice if you can co-locate these facilities with a pre-existing telecom co-location or data center use. The idea of turning raw space into a hotel is something we really try and avoid unless geographically we just don't have a choice.
Or the data center's expensive.
Thank you.
Right.
Other questions?
No, it doesn't look like it. Yes, we do.
Hi, Steve with the Mer Group. Can you make some reference about options for in-building DAS for residential, high-rise residential, of course?
So I'll take in-building DAS. So the high-rise residential has been really a difficult one for many, many years. And I think what's going to be required for those type of facilities is really the next generation of hardware. So whether it's a small cell solution that just gets on the Ethernet, or whether it's a DAS with basically small cells at the front end, it has to ultimately be a solution that the enterprise can deploy cost effectively without having to wait for the carrier to fund anything. As long as a carrier has to be asked for permission to buy a box, the reality is you're not going to get it. If it's a big building and every carrier wants to be in there, you're not going to have any problem. It's the other 70% of the buildings in the United States that carriers don't really care about because they're just not optimally for their ROI. It just doesn't work out. So if the enterprise can buy all the equipment to make the thing work, and the carrier says, yeah, I'll sign off and you can make it work, then we'd see a lot more deployments, in those type of environments. And then, of course, there's costs associated with it. So, I mean, that's my view on the high-rise, residential.
I'll add on to that. Again, this concept of base station hoteling helps that model because we're eliminating that cost of that space in that one high rise, and maybe it's 20-story, 40-story, but it's eliminating that cost. And you're also going to see something else happen in the future. It's going to be a little tricky with 911 regulation, but right now there's no real in-building 911 regulation. But imagine if you can, that you could take that capacity from 9 a.m. or 8 a.m. to 6 p.m. when nobody's in the residential building, they're all in their office, right? So you could take that same base station resource at the hotel and migrate it. It doesn't have to be to whatever building you're going to, but you get the point. You migrate that. So now you've got a better efficiency on your small cell or what have you. I think the other thing here is going to be, as Ken said, is the drivers, not only from technology, but it's really going to be from tenants. I was just telling this story earlier today. I went to go help some guy do an assessment of his building to get a certificate of occupancy. It's got to meet fire code. The radio's got to work in the building, right? And I looked at him. I said, "Have you considered putting?" Again, this is a big residential building on the other side of the Hudson. I said, "Have you considered putting a DAS in here or something?" And he goes, "No, why?" I said, "Because there's no coverage in here. If I were to come, and this is a brand new build, if I were to walk up to this building and look at my phone, I'd say thanks, but no thanks." And I think you're going to start seeing that happen. We're talking with REITs that are starting to realize Class A office space, residential buildings. It's because, again, we're prolific. Somebody's going to pay for it. Might as well put it as an underlying bill in the lease, or in the buy of the building, but it's going to start happening. And again, this model that we've been talking about helps that move forward.
Well, to the panel, I think we're out of time. So to the panel, thank you very much for the presentation. Thank you to Nidas for hosting us, and thank you to ZenFi, our sponsor.
Thanks.
Good job.